go. Okay, so hope you're all doing good today. Much better. Like pretty much 100% now. But yeah, so you all watch the videos hopefully for the makeup. So the idea today is just to kind of reinforce that material with some sample code and to make sure that we are all on the same page when it comes to 2D and 3D dynamic arrays, and maybe shallow versus deep copy, and a little bit about constructors, right? So I have here what I think is the video that you saw, the notes. So some comments I want to make sure that you all kind of understood that. But the big thing when making, two-dimensional arrays is that you're making these pointers that are going to point to other pointers that are going to point to actual lists of information. And so, C++ only allows you to dynamically allocate 1D arrays, right? So like if you're going to go ahead and say like int new, as we saw when I first showed you the arrays, when you want to make an array, you can go ahead and say something like, car, word gets new car, and then the size of that, right? So if it's an integer, you can say something like int pointer gets new int of size 5. Now that 5 can be a variable, right? It can be anything that you want. You no longer have to have it defined at compile time. It could be something that the user enters. But the point is that when you're doing this, you can only create 1D arrays. That's it. So when you want to do multiple dimensions, like what do you do? Well, that's the whole idea with this arrays of pointers. You're going to, instead of making an array of data, you're making an array of pointers, right? So we have this array that we're making, and it's of size 4, but that array is not holding the integers themselves. It's holding pointers to other arrays. And again, if you sort of unwrap that, this is kind of what it looks like. We have the array there with 4 pointers, and each of those pointers is going to basically point to a 1D array. And that's how you make basically a 2D array. So here we have a 3x4, and so you could think of this like having 4 pointers, and each one's going to point to each row. Okay, so you can dynamically allocate that, and you can dynamically allocate each of these. And that's basically the idea for the 2D array. And then the 3D array is the same thing. The 3D array, instead of making these these arrays to be of data, you make them of pointers as well. So it's like doing this multiple times. So like with the power of copy pasting, I'm just going to make a bunch of these. 3 is enough. And then I'm going to make one array with 3 pointers that basically links to these. And what this looks like would be essentially a 4 by 3. I don't like that. Let me make that again. Looks not nice. Or 3 by 4. I don't know which number you read first, the row or the width, technically. But you have this. But now you have 3 of these, right? Stacked on top of each other. So there's your depth. Like that. Good enough, okay? So that's your 3D array right there. So you got pointers that point to more pointers that point to actual data. And of course, this whole thing is referred to a one single variable, right? Which is another pointer. So technically speaking, that would be all the pointer tiers you have. However, as you saw in the video, and as you see here, when you're making a 2D array, you don't put one asterisk, you put two of them. Yeah. Some people call this a double pointer, but some say that's a misleading term, so I'll leave that up to you. But I think double sounds pretty nice. So the reason why there's two asterisks there when you're making a 2D array is because you have two layers of pointers that you have to traverse. Like here's one, and let's say you're going to this one, there's two. So to actually get to real data, which is this, you have to go to two stars, right? Let's look at this example with the 3D. How many stars do you have to go before you can get to some data? Let's say that we're looking for this number here, that's a 42. Well, you gotta go to this one, which is a star. You always have one star in the beginning, so you go there, 1. And you go, let's say, to this one, 2. And then you go to this one, 3. So that's the path you're taking. And then you get to the 42. So you have to go through 1, 2, 3 stars to get to 42. So because of that, that's a 3D array. And if I wanted to declare this, I would have to use 3 stars to actually create this pointer. So 1, 2, 3, call it R3D or something. Okay? And then if you're dynamically allocating that, you say new int 2 stars, because you're making the second array, right? Here you make 1 star, but here you make 2 stars. And you make this of size 3. So that is making the array that is currently in green. Okay? Now, if you want to make the arrays that you're about to see in yellow, those will be declared with something like new int 1 star 4. But you got to make 3 declarations of those, 1 for each of them. And those could be held in a pointer with 2 asterisks. So like, let's say PTR. These 2 asterisk pointers that you're seeing here are exactly what you're making over here 3 of. So those are these. Okay? And finally, these are holding, these subarrays here are holding single asterisk pointers, right? Which are these guys, right? And so if you want to actually make those allocate data, that's when you do your new int 3, and those are going to be all of the tiny squares. Okay? No asterisk, because they actually contain data, not pointers themselves. But if you wanted to make like a 4D array, then these could be pointers, and then your next layer would actually be data, right? So it's like, it's a way of storing multi-dimensional data in one dimension, really. That's what you're doing. Because remember, all this stuff is going in main memory, and main memory is just one array. That's it. There's just one single array. So you're flattening something from higher dimensions into one. Okay? So yeah, that's kind of hopefully a good review of this. Let's just run it through some examples again on code. Again, I'm kind of expecting that you actually watch the videos so that you understand this stuff, right? So let's just jump right in and make that 3D array. So if we want to make that 3D array that you saw here, we are going to start by making that pointer. Let's make the array of characters. Sorry. There we go. I guess I clicked on OBS and then I pressed the keyboard shortcut that must have done something. But yeah, so let's make it an array of characters. I always use integers, so you know, I'm trying to make it for a difference, you know. In fact, actually, let's make this be a value that the user enters. In fact, let's make that be its own array. We're gonna call it dimension. Yeah. Let's make a tiny little array, but because we want to be so pointer happy, we're gonna make that array even a pointer array too. Okay. So int pointer dimensions gets new int array of size 3, and then we're gonna store there the 3 dimensions that the user enters, which we're gonna read in. How about that? Just a little prompt to enter all the dimensions for the user so that he can enter the 3 dimensions in. Okay? So now that we've done that, we are going to use those dimensions to create our cube of characters per se. You know, we could actually make this 4 dimensions, but nah, let's stick to 3. Because, yeah, we don't want to go too crazy. And so, because of that, this is going, I don't know, we could really pick any dimension to be the first one, but we're just going to say this is the first dimension. That's going to be the biggest one. So like that. Okay. Just to be extra fancy, let's make some pointers that are just, let's call these aliases of actually the dimensions, just to make it nice. Okay, so we're going to call it xdim. So int pointer x dimension is just going to basically get whatever dimension 0, address of dimension 0, just because it looks cooler. It's totally unnecessary, but you know, we want to get as much practice as we can with these dimensions. Why is the dimension dynamic calculations not runtime? Simply because, like I said, we are very, very pointer happy today, and I just want to show as much dynamic as possible. But yes, you're right, I neither need this stuff nor to make this actually like dynamic, but I'm just literally throwing as much dynamic as possible because it's more examples of dynamic. We all know how to do arrays at this point without dynamic, so yeah, these are completely unnecessary, but you know, just because it's cool, we'll do that. Okay. Yeah. All right. So this here, as you can see, wouldn't. Oh, yeah. My bad. Thank you. Good catch. Yes, good catch on that. Yeah. Okay. So yep. I was thinking of using an auto here, like an auto loop, just to avoid weird things, but I was like, no, that's too much. Okay. So that all looks okay. This dimension will do like this, but maybe the y dimension will do like this, so you can see the differences of all of them. Bam! So this is making just a pointer. Actually, it's making an array, but it's making the so array R3D is the purple one, is this one, but then the car to asterisk xdim is going to be the green one that you see here. Okay, so now we want to make the yellow ones. Okay, so to make the yellow ones, we need a little loop. The loop is going to iterate the number of entries in our green array, which is the x dimension. So I is less than the contents of x dimension. We could use xdim, or we could use dimension 0 here, but I'm going to stick to xdim for this one. And I++. And so the reason why we need to make a loop is because we need to call the new, we need to make this line that you see here, the new int 4, we need to run that 3 times. Well, actually, we don't know. We need to run it some amount of time, whatever the dimension of x is. So that's why it's a loop. versus like a hard-coded line in this case, okay? There's two ways that you can do this. I'm gonna make it the really naive way first, the easy way is I'm just gonna make a temporary pointer, call it temp, and I'm gonna make my next dimension, which is going to be the yellow pointers with that. And the size of this is going to be the size of dimension 0. Now, I could do the widen here and be consistent, but I want to show you how you would do it without that. So in that case, you could just do it like this by just copying this. Okay, just so you can see two versions, you know, one with this pointer and one with this temp pointer per se. Okay, so this is making arrays of size y dimension. So that's making it of size 4 if this was the case for the yellow ones. So that makes the yellow one. So we just made one yellow one. But now we got to make this link here. We got to make this link right here. We got to link that together. We could have done this again in one line of code, but I'm doing it in 2 lines to be more descriptive. So here what we need to do is we need to actually take R3D at the index that we're at, I, so 0, 1, or 2, and actually assign that array. So you could do it like that. Now, you could have done this all in one line of code, and it would have looked like this. Okay? I'm going to leave it commented it out now. Why is it giving me an underline? It's probably just Visual Code being weird. Oh, wait, no, I see why. The D. Yeah. But yeah, that, you could have done it in one line. I'm going to leave it commented it out, but yeah, that will be the one-line version of that, okay? All right, so this is going to run for each of these green pointers, okay? So 1, 2, 3. For each of those, it's going to make one of those, one of those, and one of those, and it's going to link them. Like link, link, and link. Okay? So, yeah. We have now made the green array and the yellow arrays. And we also have this pointer here. What we don't have are the actual data arrays. So, you know, they're kind of off screen, but all the gray stuff. We need to make those. How do we make those? With the simplest declaration without any asterisks. We need to make how many of those? Well, each of the yellow ones need 4 of those, or whatever the number is we'll pass in. So we need to run a loop that makes 4 times this new int call. So what we need, I'm going to write it just here first, is we need to put, oh, by the way, it got cut off there. I see that now. But it's just that here, okay? In case you didn't see that earlier. But yeah, so what we need to do is somewhere in here, we're going to make a pointer, another pointer. We can call it temp2 or whatever. Or temp, just to vary the name, temp_ptr. And we are going to make that be some new int of size. And then we're going to pass the last dimension, so the z dimension. So this time I'm going to go back to using this. Just because why not? Again, I'm trying to show you variations of the way you will write the code. And then you are good to go. Why is that complaining? Oh, I said nint. Why I put enter? Rent car. Yeah. Thank you. So, yeah. We need to run this line of code and make like 16 of these or something, or 12 of these, I guess, since we have 4 of these. Yeah, 3 of these. So we need to run that line 12 times. 4 times per each yellow. So that's why it makes sense that we want to put this inside a for loop, which is like a nested for loop, right? Because then it's going to run 4 times, and then the outside loop runs 3 times. So 3 times 4 is 12, which is what we want. So we're going to say for int I, or actually a different variable, int j is equal to 0. J is less than, and in this case, we could say z dimension, but I'm going to use the old method with dimensions array. Spot 2, and then j++. And now, the code the way we have it, I'm going to get rid of this thing now, since we don't need the pictures. No, we kind of do need, yeah. So let me, Hold on. I need to do this. Just stand by. Okay. There we go. That's a little better now. Preview. Okay. Yeah, because that's painful. Because I mean, the zoomable one's okay, but the one with the tablet is like moving things around. So yeah, okay, that's a little better now. Okay. So yeah. All right. So yeah. So now what we're looking at here is we are running this 12 times to create the gray ones, but they're just being created like in the middle of nowhere and nothing is happening. It's not being linked. So what we want to do now is we want to take this and actually put it in an array. So we want to make these connections here. So we want to make these connections, all of those, from the yellow to the grays. So in here, we're going to say AR3D, so that's the name of this array, at spot I. So that spot I means going from here to here. And then at spot J, which is going to be going from here to here for each of these, assign our little temp pointer. Like that. Okay? So now we have linked the yellow on the gray ones. Of course, again, this could all be done in one line of code. Let me go write that in. It's just basically that. And maybe for this one, we will comment out the 2-line version and leave the 1-line version. Okay, again, I will be uploading this code after class to the Canvas. Same link as always, it just gets updated. Last week there was no updates because we didn't write any code actually in the computer, but this time this is code, so yeah. And if you want to see the code from the videos from before, that's also on the same page, like from the last semester as well. So, yep, okay. So that's it, we're done actually at this point. The array has been created. However, you know, if I run this, actually let's run it just make sure it doesn't crash or segfault. But, oh, it's already running for some reason. Or maybe it's infinite looping. Or hitting a breakpoint, or what's happening? Terminal will be used by task. Something is messed up. Oh, okay. It was just really slow. Weird. All right, let's do some dimensions. 3, 4, 2. Done. Okay, so it doesn't crash. Very good. Let's take a minute here and stop. This works fine, but something that I haven't really shown you yet, and I don't know how in depth I went in the videos that I made you watch for the last class, is about Valgrind. So let's take a moment to talk about our savior, Valgrind. Okay? So Valgrind is our friend and our enemy. So what is Valgrind? Let's make sure that this is actually still the same file I'm thinking about. Yep, okay. So Valgrind is a command line tool, and I'm going to bring this down so you can see it there. So Valgrind is a command line tool that allows you to, I can get rid of this now. I don't need that anymore. Yeah. So it's a command line tool that allows you to run your program in a sort of virtual environment that keeps track of memory allocation and allows you to then be able to know whether you're the allocated memory that you used. It's very inefficient compared to running a program without all this stuff. But again, it's not meant to be run in like a production environment. It's meant to be run in a debugging environment to check for memory leaks. And it doesn't really work with massive programs. It works with baby programs. How will we delete the array after runtime? I'll get there. But first I want to show you how we haven't deleted and all the memory leaks it caused. Right? So to use Valgrind, make sure you compile your program as normal. Although there's probably some flags for Valgrind to make it better. Maybe do -G. That's also good for debugging. You can run your program as normal here. And of course, we're not deallocating the array. So right now, even though the array gets returned to memory once the program terminates, in that little gap between when the array is created and then when the program ends, we have a memory leak. So if we want to see that, we can see that with Valgrind by typing Valgrind in the terminal and then doing /a.out. If you don't have Valgrind installed, like I don't here, you can just go ahead and run sudo apt install Valgrind. Okay? Although probably, yeah, sudo, I'll do that. Yeah. And then let me type in password. That was not the right password. So if give it a second. There we go. It's going to do its thing. And then we'll come back to that when it finishes, okay? Yes, it is installed on Sally, Bobby, and all of the other servers. I actually didn't know it wasn't installed here, but I'm glad because you got to see me how to install it. So it'll take about 2 to 3 minutes to finish. Actually, no, I might be done by now. 58%. It's getting there. But, I recommend that you install it yourself as well in your local machines because you don't have to rely on servers and, they get overloaded like before due dates because everybody's trying to do the same thing, especially with stuff like Valgrind where it's like resource intensive. But anyways, when it finishes like this, you can type in clear and then you can run it. And bam, it runs. Yay. Okay, that was painless. Half the time when you try to install something in Linux, it doesn't work. So that was pretty good. Okay, so let's do the dimensions again. 3, 4, 5. And we can see here a couple of, that first issue is a little scary actually. What is that? Invalid write of size 8 at main line 23. What is line 23? Line 23 is the Z dimension. Address is 0 bytes after block of size 32. That's definitely an error with our code that this is not like. I see the error. I see the error in my ways. So the error is this should have been 1. And so what was happening is if you look at my my picture here, when I was creating the yellow arrays, I was supposed to make 3 of them here, or in this case 4 of them, right? Actually no, 3 of them, the way I wrote it. I was making 3 of the yellow ones, but the yellow ones should have been of size 5, or sorry, size 4. So actually literally what I have here, perfect. Yeah, the only difference is that the gray arrays were size 5, but I was supposed to make 3, 4, 5. So when I was looping and making the yellow ones, instead of using the right index for this, actually, sorry, when I was looping to make the gray ones, instead of going, 1, 2, 3, 4 and stopping there, I actually did 1, 2, 3, 4, 5. So I was making an extra array there, which was really, really bad because I don't own that memory, right? So nasty memory leak there. So I was, instead of making 12 arrays, I was making 20 of them or something, basically. So the fix for that is here. That I should have been using the Y dimension, not the Z dimension. So accidentally, it's a happy mistake because now you've seen how Valgrind can help you find these kind of mistakes. I didn't catch that. Nobody caught that on chat, or if they did, they didn't say anything. So let's see if by changing that line of code, it fixes that error. 3, 4, 5. Yeah, look at that. Error fixed. So great example of how Valgrind can help us. In this case, not just yes, it was a memory leak, and yes, it was bad because you were running out of the array. But that's the bigger issue. Like Valgrind just helped us fix our code and make it much safer. So it wasn't just about memory leaks with Valgrind. It actually improved our code. So pretty good. Just curious if there is a STL function that will create this array for us. Yeah, it's called vectors. Just make a vector. Bam, done. So yeah, you would never do this in real world unless you have some optimization reason to do so. You would use like you said, a library. But yeah, you can use, like, if you're doing machine learning and you need like a multi-dimensional array stuff, there's like NumPy and things like that for Python, and there's probably something like that for C++ to make like easy 3D arrays. But if not, vectors is probably the best way. Yeah, I'm sorry, I'm not too familiar with C++, like that kind of stuff. I use Python, so in Python, you know, it's easy. But I'm pretty sure there's some like 3D array libraries or something like that. But yeah, but vectors will get you there. Anyways, I should have scrolled around more before I fixed the error. But now you can see that it says error summary, 0 errors from 0 context. Let's actually go back and make the error again. I like to see that more. 3, 4, 5. 3 errors from 3 contexts. So yeah, I think if there's a flag, yeah, we run with S. So dash S. That doesn't really give me more errors. Maybe I have to put the dash S before that. 3, 4, 5. Yeah, okay, there we go. I think this gave me some more description of the errors here, as you can see. But it's kind of the same thing it's already told me, so yeah. But anyways, you saw that the fact that it told me an error was really good, because the compiler didn't warn me about that. It doesn't know. So yeah, no errors. So you definitely want 0 errors from 0 context. That's what you want. Anyways, now looking at the memory leak aspect of this, we can definitely see that there's a memory leak. Definitely lost, indirectly lost, and possibly lost, still reachable, suppressed. Still reachable, that's usually like a dangling pointer. Not as bad. Still bad, but not as bad. Possibly lost is like, I have no clue. But if you have something there, it's probably like, it probably is lost. Unless you're using like something like the CN library, or sorry, the stdio library, like the standard input, will like used to always show a possibly lost in like older versions of Valgrind. I think that's fixed already in this version of Valgrind that we just installed, but that used to always show up for me. But yeah, this is definitely us. The 36 and 156 bytes. And if we do the math, you know, this should make sense for the most part. Let's see, 36 plus 156 is 192, okay? So let's divide 192 by 4, and that gives me 48. So how many of these do I have? Well, I have 3 times 4 times 5. So 3 times 4 times 5 is 60. Oh, well, by the way, 192 was here. But yeah, that's weird that it's 60. I guess we're not losing all 198 of them. We're only losing 48 of them. Well, 4 times 5 is 20. I'm trying to do the math on how it's calculating only 48, not 60 lost. Because like, I would assume that it would be 60 bytes, oh sorry, 60 integers lost, right? Because these integers 4 plus the actual lost memory of the pointers themselves being declared. So I'm surprised that it's not giving us more. Oh wait, no, but they're characters. We make character arrays. So maybe that's why. That's probably why. They're characters. So I shouldn't do 192 divided by 4. I really should do 192 divided by 1 maybe, but there might be kept as 2. Okay, that's really weird to do the math. If we made them integers, then this should in theory add up. If you add up all the integers plus all the pointers, then it should actually add up with what Valgrind gives us, okay? So it's actually okay. It's just that characters can get stored in weird ways in the pointer world here. They're probably actually using only one byte per character because they're arrays. But when you only have one of them, they'll use 4, and the math gets really weird. The way it's getting 48 though, it's just like, I'm not 100% sure. It's probably something like 60 plus like a couple. Yeah, no, I don't want to have to do the math. But, you know, try at home making this with integers and the math will add up, okay? The pointers are the same size, yeah. So the pointers will be 4 bytes. So of those, we have lost like, well, if we did 3, 4, 5, then we have 3 pointers lost in the first array. And then we have 12 pointers lost in the second layer of arrays. So you know, we're trying to really do the math. We'll try really fast. We're probably not gonna get it right. 3 plus the 3 times 4, which is 12, plus 3, 4, 5, which is 60. So these count for 4s. So we multiply them times 4, we get 12, 48 plus 60. That gets me 120. And then I guess, yeah. However, we're getting 192 lost. So the discrepancy there between the 120 and the 192 is because these 60 are not being kept as individuals in all cases, maybe. So, you know, yeah, I mean, it's close. There's 72 unknown somewhere. So this is for sure okay. This is the one where like it could vary because of the characters. You also allocate memory for the size of the dimension. Yeah. So this 12 and 48, these are all pointer memory allocated. So that's accounted for. And this is actually the data itself. If we change these from cars to integers, then the math will add up and be okay. But we were doing it with cars, so who knows how they're being stored. Okay? But anyways, let's go ahead and fix our memory leak by deallocating it. So let's just let's make another array. When you deallocate, you want to go from the inside out so that you don't access dangling pointers. But it's usually going to be the same loops that you did when you allocated with the same variables, to the point that you could literally copy and paste. Like, I could copy and paste this over here, but I'll just write it again. There's loop 1, and then we're going to make loop 2. Next dimension, j++. And then you don't need the third loop because we have that delete operator that we can use. So that can actually work for arrays. So we'll just do that. So delete array, and then we'll do AR3D of I and j, like that. And that should actually be all that we need. Oh wait, I guess technically once we finish, we gotta delete the pointer arrays. So we'll need we'll actually need brackets for that, because we want to delete the pointer array that is at 3D I. And then after that, we want to delete the pointer array that is the green one, the big one. Oh, sorry, my bad. Yeah. Sorry. Okay, here we go. So what I did is I created two for loops, literally the same ones as the ones before. So these for loops, copy paste or just rewrite them. So you're gonna iterate to the first 2 dimensions. You don't need to do for the last one. And then you're gonna call delete, and you're gonna use the delete array instead of the delete individual. That's why you don't need to do the third one. If you wanted to fill it in though, let's fill it in actually before we delete it with stuff. That one you do need 3 loops for. If you're trying to fill it, because you want to do it, you want to access each individual element of that array. So like k is equal to 0, k is less than 0, or sorry, k is less than the z dimension, k plus plus. And then like, let's just assign a random Ascii value actually. So AR3D I J K gets, how do we send a random Ascii value? We can use a ternary operator. No, we could use a, so a rand, so the Ascii table goes from 0 to 128, but I don't want to use, that's correct. So we'll call rand mod 128, and then, I mean, that'll give us a valid ASCII, but it's going to be like, some of them are going to be weird, not letters. They're going to be like punctuations and stuff. Ideally, I would want to do something from like, yeah, okay, so what I'll do is, so if you look at the ASCII table, here, let me actually open the ASCII table on the side. ASCII table. I kind of really want like actual characters, so maybe from like 33 and on. So 33 to 127, let's do 127 minus 33. I really don't need this, but I'm tired. 94. So actually we're going to do mod 94 and then add 33 to that value. And then we don't have to do this, but I feel better doing that. So we're going to cast it to a character. So it's actually stored as a character and not some integer, which it would have done anyways, but I'd rather do it by being explicit about that versus implicit. We don't delete that one because those are all cars, not dynamic. Yeah. Yep, you are indeed correct. So anyways, that should fill the array with stuff. So after we fill it, let's just let's print it all out again. So I could do this in the same loop, but I'll do it in a different loop just because you know, I don't want you to think I'm cheating and like not actually doing this. For this, to print it out in a somewhat clean way, we're gonna need some line feeds. So maybe like, so all of the same row can be printed together, just a space between them. So we can say AR3D I J K C out that, and then put a space between them, and that's all we need for that. At the end of these rows, we can put a line feed, and then how do we do the third dimension? We'll just flatten it by putting another line feed. We'll put two of them here, like that. Okay, that'll work. Anyways, back to the allocation stuff. So this is the important thing. So we don't need to have that third dimension individually because we can call the delete array. So we don't need to do any member specific deletion. We could, you know, in theory we could do that and it might work, but it just sounds horrifying to do. Like you could in theory do that and just call the normal delete. I've never done it, but I think in theory it'll work because of the way delete works anyways. But I would not recommend it. So yeah, kind of curious to try it now, but I don't want to do it right now. We'll waste too much time with that. But yeah, just call delete and then call the delete on this. And this is a pointer to one of the gray arrays, the last dimension. So they'll kill it. And then this will delete the pointer of the yellow pointers. Here, make sure, I don't know if y'all remember the colors that we had. But we got yellow, gray, and green. So the first delete here is going to delete one of the gray ones. So that's going to go gray, 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 gray. And technically this is one yellow pointer. So like this line, when array 3D like I is 5 and J is 2 or whatever, that's one of these pointers. So that's saying whatever that's pointing to, so like this, delete that. So bam, kills it, kills it, kills it, kills it. Well, deallocates it. It's still there, but deallocates it. I think the video had delete at the end. I don't know what you mean by that. Clarify, I guess. But yeah, so you delete that. And then the delete R3D there, that's going to delete the yellow arrays by going to the pointers here. So this is 1, 2, and 3 pointers. So R3D0, R3D1, R3D2 are these pointers. But you still got to delete this guy. So yes, you still got to delete this one. To delete that one, maybe that's what you're talking about. Then out here, you do delete array, R3D, like that. And now you've killed the green array. So now all you have left is a single pointer. But now, to avoid dangling pointers, you can just say R3D gets null. Dangling pointer? That sounds funny. No. Uppercase it or use null PTR. Yes, so yeah, you're right. Yeah. I just hadn't gotten there yet, but yes, you were correct. Okay. And then just don't forget all your semicolons in the world. And yeah. Okay, so now we did a lot of things here. So let's see if, we'll run. This is not the way to code. You want to, like, if you were coding this at home, you would do what I did first with just allocating it, testing if that works, then try inserting stuff, test if that works, then try printing out what you inserted, test if that works, then do the deletion, test if that works. Doing everything at once is a great way to just crash and be stuck. Hopefully we don't do that. But then again, it's not the same since I've done this like 50,000 times versus you guys are starting out. So yeah, we still got a bit of a memory leak, but interesting. Did I not call the delete? Delete. X, Y. Maybe these are flipped. Who knows? Okay. Oh, I know what. This array, the dimensions array, we never deleted that. Since we were so crazy with dynamic, I forgot we did that. So yeah, the dimensions array is also dynamic, so we need to call delete dimensions. And then, technically speaking, we should also set this one to null. Three, 4, 5. Oh, now we got some like nasty error. Was that not dynamic? Oh, yeah, forgot the square brackets. 3, 4, 5. Okay, now we're good. Okay, so error summary: 0 errors from 0 context. Heap summary: in use, 0 bytes and 0 blocks. Great. So we can see here the array. So as you can see now, it actually, it's full of valid characters. Well, you can't see it, but now you can. Okay, so let me scroll up so you can see. So first we compiled, we ran it, and we had issues that said, which was the first one that we ran actually? This one. Definitely lost 12 bytes in one block. 12 bytes, so that would be 3 pointers. And it turns out that was a dimensions array. Actually, not 3 points, 3 integers, which is the same thing. 3 times 4, 12. So that I was like, why is that deleted? So that's what we found out. Once we fixed, well, I tried to fix that, but I called delete on a single pointer instead of deleting the entire array, which actually gave us a bunch of complaints because it's like yelling at us. So I guess to answer the other question about if we could have done that individual delete, Valgrind would yell at us, even though it doesn't crash. But yeah, it's yelling at us because we're trying to delete or deallocate or free a pointer that is part of an array of memory versus like an individual one. So it just got really pissed off at us for doing that. And gave us a bunch of errors. But when I fix that, then it'll stop complaining. And as you can see also, the random generation actually worked out pretty well. And this, I mean, it's kind of hard to make a 3D box in the terminal, but this is good enough. You can see this is the first sort of like layer, second layer, and third layer. And you can see that this was different than like this one. Actually, no, they're all the same because I forgot to turn the seed on. But we can do that. Actually, we don't have to do that. But what I'm saying is you could do that very easily if you wanted to. By going up here and saying, what is it? It's like srand null, I think, or time null. I think so we can use the time as the seed value. So if we do that, and then we run it, Oh, ooh, this is gonna be massive array now. Jeez. Okay, let's not make something so massive. 3, 4, 5. You can see now that we have some stuff, but if I run it again, 3, 4, 5, it's different stuff now. You see that? So truly random array of characters. But they're all nice characters, and not like there's no weird stuff. It's just letters, numbers, and a couple of special punctuations. So I'm relatively proud of that array. I saw someone recommend the usage of null pointer instead of null. There is a difference, but at this kind of level, it doesn't matter. So null is like literally a 0. So when you're assigning like C++ does not like you assigning numbers to addresses. It'll yell at you, with the exception of 0. 0 is like, okay, I let you do that because I know you're doing that as a way of signifying something as null. So I believe that the keyword null is just the same. It's like a macro for 0. So in modern C++ 11 and whatnot, they created a special term for null PTR, which is what most of the libraries use. So if you're comparing what the library is using to null, you may run into some issues. So when it's your pointers that you've made, then yes, you can use null. But when you're dealing with a library, it's better to use null PTR. So the consensus is just be consistent and always use null PTR. But null PTR doesn't work with old C++. So then your code is no longer backwards compatible. So that's the argument against it. So, you know, use whatever you want. Technically speaking, null PTR is going to avoid some headaches along down the road. So, you know, if you're already using C++ 11 things like vectors, then you might as well just use null PTR. But for me, it's more writing, so I'm lazy. So it's less writing to write NUL than NULL than to write NUL PTR. So yeah, that's why I use null most of the time. But like I said, I don't really do a lot of C++ coding these days, so except for class. I do mostly Python. So well, I thought this would take longer, but that's kind of the meat of what I wanted to show you today. Like I said, hopefully this is review from the videos as well, you know, that you watch over the week, Monday or whatever. Very briefly, I would like to point out some things. So don't forget, test is going to be a week from today. So it's no longer on Monday, it's going to be on Wednesday. And I'm not making the test, but the test will cover up to like pointers. It will not cover virtuals, which we'll start talking about next class. So yeah, that's good, I guess, right? Anyways, going back to this, shallow versus deep copy is an important concept that I don't know if the video covered it yet, but I do wanted to bring it up. So here's something interesting that happens when you copy arrays. So when you copy a single variable, like, and what I mean by copy is like, if I have something like int a gets 5, and then I make an int b gets 6, and I say something like a gets b, I'm copying essentially the value of b into a, right? So a is going to have a 6. If I modify b afterwards, it's not going to modify a, right? Like once that copy is made, there's no association or link between them. That's good. It's kind of what I want. If I didn't want that, then I could use a pointer, right? I could say like int p, and then say like the address of p, so p gets address of like b. So now this is pointing to b. So it's not an actual copy. It's just an aliasing. It's a reference. So like if I modify b, p is going to get modified indirectly, right? And if I say p gets 10, and then I see out b, then b is going to contain 10, right? So that's an aliasing. That's kind of like a shallow copy per se. It's not a real copy. They're not independent of each other. They're linked. Okay? Now this is very basic and obvious and blah, blah, blah. With arrays, things can get kind of nasty. when you make an array, first of all, I think if you make an array and then you make another array, like if you do something like this in C++, well, here, let's just try it actually. I'll just do it at the top. So if I do something like this in C++, and I say something like A gets B, I think it's gonna really get pissed off and yell at me, but we'll see. Yeah, invalid array assignment. So it doesn't let me copy these arrays, right? It doesn't let me copy like an array into another array, even if they're the same size, because it's like, it just does not let you do that. However, let us say that we make another 3D array at the bottom. Actually, not at the bottom because we deallocate it, but maybe like before we deallocate it. So here, let's call this one array 3D clone. And I assign or copy per se the array that we already have. Now, if I run this code, it'll run just fine. It'll compile and it'll still run. Obviously, it's not doing much other than copying it, but it'll run. Okay? So, whereas with a normal array, like a static array per se, you get an error. You don't actually get an error with a dynamic array. So you're able to copy arrays by all you want. You make 1,000,000 copies of them if you want. There's a catch though. Well, there's always a catch, right? The catch is that when you're making a shallow copy of the array, which is what you're doing there, you're not really copying the contents of the array. What you're doing is, and I'm just going to take my little picture that I have, is this. So I'll shrink this a bit. You're familiar with this picture because I've been talking about it for the full class. So you have this thing here. And so what you're doing when I make the 3D clone arrays is I'm taking this and I'm making this thing called 3D clone and I'm assigning it AR3D, right? What I'm doing with this is I'm making another sort of purple pointer and I'm simply copying this assignment here, this pointer value, this address. So whatever the address of this spot is, the first element of that, that's all I'm copying. So literally, I'm taking this and I'm just copying it over here. But all this is still just pointing there. I have not made a new array. I haven't copied anything but a single pointer. As you can see, what this means is that if I go in here and I say, well, I would like to modify array 3D clone, blah, blah, blah. I don't know, 3, well, not 3 because that's mentioned, but like, this is 222. So this value 222. So where is that going to be? Well, 0, 1, 2 here, and then 0, 1, 2. So this one here, and then 0, 1, 2. So this spot right there, that spot right there is what I'm going to modify. So I'm going to put in there, I don't know, 5. Oh, shoot, I lost it. 0, 1, 2, 0, 1, 2. So 5 right there. If I go in and I print out my other array, I do C out AR3D at that same spot, it's going to have a 2 in there. So all I'm doing is this sort of referencing, aliasing copy. It's not making a true duplicate of the array. They're both the same array. What's even worse is this. Let's say that you copied it and then you want to delete this one. You call delete. You deallocate it. Guess what? You still have access over here to it, right? And you can still modify it. You're just accessing a dangling pointer, which is really bad. You can crash a program. If this is inside a class, things getting worse. Like it just becomes an utter mess. However, sometimes shallow copies is actually what you want to do. That's okay. Like if you're passing like some massive array to a function, like we saw with the first assignment, a shallow copy is okay because you're just passing a reference to it. You're just passing a pointer so you can access that big massive array. That's fine. Just be aware that that's what you're doing so that you don't assume that it's a copy of it that you can modify, delete, or whatnot. Just know that you're just passing a reference. It's not a real copy, okay? and that maybe you should add a const so you don't accidentally modify it or whatever. So again, it's not necessarily that you don't ever want to do this. It's just that there is a time and a place for it, which is when you just simply want a copy of a pointer because you're trying to access the data without having this massive thing. And this was, again, an issue in assignment 1 because, like, there was at least one person that I had to help because, like, you know, when they were passing the unigram stuff, they were passing, like, the 50,000 array every single time they were searching for a word or something in the inline function or whatever. So like all that copying back and forth, like, really slowed down the performance of the program to like the point that it was timing out in code grid. So all we did was switch pass by value to pass by reference. So there's time and place for this. However, let's say that what you want to do is actually copy the array. Like you want 2 complete copies of this so that you can actually like modify them and do whatever. Then it's not going to be enough to just write this single line of code. Unless you know operator overloading, which we'll learn at some point in the next few weeks. Quite a while from now, though. Actually, not that long, but definitely a couple of weeks. Unless you learn how to do that and then can actually modify operators so that you can do a single line of code, the normal way to do this is to actually create a loop that is going to manually do what's known as a member-wise copy. So the sort of, I won't say algorithm, but like the sort of the steps that you have to do to make a deep copy or a member-wise copy is first allocate. So step 1 is, well, I guess basic step 1 is create new pointer. So like 3D clone, just create that, whatever. Step 2 is allocate new array. So go in through your loops. If it's a 3D array, then go through 3 for loops and allocate all of the memory for the array. So like a complete new copy. So basically copy and paste all the for loops with the new calls. When you've done that, then go ahead and make the member-wise copy. So loop through each member. And copy it. What this means is that I'm going to have to make 3 loops for the 3D array so that I have something like this. So I have for I is equal to I to the x dimension, and then for j, same thing, and then for k, same thing, and then finally here I'm going to have a line of code that is going to be something like AR 3D clone I j k is equal to AR 3D I j k. Okay? Like that. You're gonna have this massive line that copies it. And when you do that, only then can you say that you have made a deep copy. So you have to create a new array that you want to make, allocate all the memory for it, and then go through a for loop and just copy each individual member like that. When you do that, you can say that they're a copy of each other and they're independent of each other. That also means that if you're going to deallocate it, you gotta make sure you deallocate that actually on its own. Okay? So that's the difference between shallow and deep copy, and it's important that you understand it because you want to make sure you're aware of that so you don't accidentally deallocate things you don't want or modify things that you didn't intend to, right? Trying to make a copy of data to modify it on a function or something. Be aware whether it's a deep copy or a shallow copy. Probably want a deep copy if you actually want to modify it without modifying the original. So that's that. And then I have a thing about constructors and destructors. So we haven't really talked about the destructor much. We haven't used, at least we did talk about it, we haven't used it a lot. Turns out that the destructor is the ideal place to do your deallocation. So anytime you want to delete stuff, you know, right now we're just doing it at the end of the code. But if this is if this array was part of a class, in the constructor you can do the allocation, and in the destructor you can do the deallocation, and then you don't have to ever worry about it. It's just kind of done behind the scenes. Furthermore, there's a thing known as the copy constructor that allows you to copy an object and make an object out of another object. That is something you want to add code to so that you can actually do a deep copy there. I'll show you what a copy constructor is at some point in the future. Not today, probably. But just be aware that that's a thing. So that, like, because here's what could happen. Let's say you have a class. And in this class, you have a pointer. Okay? And, you know, you have a constructor in your class. Actually, you know what? Let's code it. I'd rather code it. It'll be easier to show you there. Let's save this stuff so that I can get rid of it. So again, it's saved, and I will be uploading at the end of class. So final example of the day. So we're going to make a class called A, and we're going to make a pointer. And let's make a constructor for the class, just default constructor, where we're going to allocate the pointer. And then make sure you, just to make life easy, make them public. And then let's make a destructor to deallocate that pointer, since it's just the ideal spot to do it, because the destructor runs when the object goes out of scope or when you delete the object. And so it's just the perfect place to actually do a deallocation. I mean, since the object goes out of scope, you don't really need to do the null PTR stuff, but no, you can. That'd be extra safe, I suppose. Anyways, that's the basics of this. However, let me show you what can happen if you're not careful about this. Okay? So make an object called A, and make an object called other A. Okay? You know, I can access the PTR and I can dereference it and say something like 5. And then if I would like to copy it to the other A, I could say something like other A.ptr gets 10, or sorry, gets A.ptr its value, like that. You know, and then if I print it out afterwards, I should get a 5 out of that. Oh, forgot to put this semicolon there. Actually, I can just run it here in the VM in VS Code now. Cancelled. Okay. Get rid of that breakpoint. Here we go, 5. Okay. So yeah, so this is all good. No surprises there. You have to be careful though, because if in this line of code you say other APTR like that, you're still going to get a 5 out of this. But now this is a shallow copy, right? How am I getting all these errors? I don't know what's up with this. But yeah, this is a perfect. I like this. This is good. Yeah. I actually forgot about, didn't intend to do this, but I'm so glad it happened. So that's the first error you're going to run into here. So I actually have an error that I got. In fact, let's see what that looks like in the actual terminal. Because terminal, you know, you all post on Discord and whatnot, like issues with VS Code. Your code doesn't work, but you know, I don't know why VS Code does not just show you the terminal errors cleanly, but really you should just look at those, because they're so much more descriptive. Although this is actually not a, you know, it's actually a pretty decent case. It's not bad. It'll be the same thing as you see here, but most of the time it's not. So definitely look at the terminal errors than the VS Code errors, because they help you so much more. But anyways, you'll see that this program actually crashes. As you can see, abort, core dumped. And that's because we made a shallow copy. But the shallow copy itself is not the cause of the crash. Here's the cause of the crash. By making a shallow copy, first of all, we created a memory leak, because this pointer was dynamically allocated and we have memory associated with PTR. So when I went in and assigned you know, to point to the other pointer, we have the memory leak there. So that's problem one. Problem two, and more importantly, why it's crashing is because when the destructor runs at the end of this function, which is main, it's trying to deallocate these two objects, right? They're going out of scope, so the destructor runs. Let's say it runs first for A, which probably does, but I don't know. It doesn't really matter, okay? It calls delete PTR, so it deallocates the pointer it created, fine, no problem, and sets it to null. That's okay. Here's the issue. The second time it runs, so I mean not the second time, the next thing it runs is the destructor for the other A. The other A was currently pointing to wherever the first A was pointing to. Sure, the first A's pointer is set to null, but the other A does not have a null pointer. So already there you have a dangling pointer issue. But again, that's not the reason of the crash. That's just another bad thing you have. The reason of the crash is because when you're calling delete PTR on the other A, it's calling it on the pointer that you already freed or deallocated. So like from a visual point of view here, you know, we have this which stands for the PTR location. And we have two pointers, right? We have the other A and we have the A. The first time it got deleted, so it's been deallocated the first time. So bam, free, done, good. The second time, it's like, oh, let me deallocate this. Yeah, but you already deallocated. You can't like deallocate it twice. If you try to deallocate something that you've already deallocated, it's like you're trying to return the keys twice to the hotel owner. The first time he takes them, the second time his like mind explodes. He's like, you already returned me this room. How can you return it again? It's like a paradox, and then the whole world ends. So basically, in general, you should never try to deallocate something twice. So like a lot of people say, oh, you know, let's play it extra safe to make sure I don't have memory leaks and just call delete like 50 times from every single thing I've used. No, that's not going to work. Your program's going to crash because you double free something. But more importantly, understand that this is happening because you made a shallow copy, and so the destructor is going to be run twice for something you didn't want. This can happen also if you are passing this into a function and things like that. So you have to be very careful. If you're passing this object A into a function and it's making a copy of the object, that's the other issue we have. So, you know, forget about this because it's bad stuff. We've seen it. So I'm just going to comment it out since you might want to play around with this later. But here's the other thing. Suppose that I say other A gets A, like that. Okay? Run the code again. Oh, it just takes so long. It's toxic. And then bam, we also get another crash. Double free detected. Similarly, if I pass this A to a function in a way passing it by value, it would also crash. Here's why. When you're making this assignment here, this is also using the copy constructor that I was talking about, that I will mention next week. This copy constructor issue is that when you're copying this class into another, like when you're copying this object to another object, it's copying the fact that it has a pointer, but it's not allocating the pointer. It's actually just copying the address of the pointer. So the other A has its own PTR pointer, but they're both pointing to the same memory location that you allocated with the first one. Yet another issue. So we're out of time now, and so I'm not going to go too in depth to this to the copy constructor, like I said. But just be aware that this is something you have to be very careful about, this shallow versus deep copy, because it goes further than just like a single, you know, worrying about an array. As for your question, what is this error called? Well, shallow versus deep copy, and then like either a double free, as you see here, it says like double free, or trying to deallocate something twice. So yeah, just deallocation issues. I think that would be a good way of defining that. But yeah, so you have to be very, very careful with this stuff. If you want, you can Google copy constructor and watch some tutorials, watch some videos too. But I'll bring it up next week, and if not, when we talk about operator overloading, I'll show you some examples. But just beware. The deeper, you have to be very careful when you have things like this, because you might not think you're doing a shallow copy, but you are. Okay? So, like, yeah, I don't think the deep versus shallow. Well, deep versus shallow may be on a test, but I don't think an example where it's in a class will be. I think it will just be the basic array example. Nope, there will be no review we're just gonna go on with material. We don't have time for review, unfortunately. Whether or not I didn't have class, we just don't have review time. So my best advice is just to practice the assignment coding, because that means you know the material. So yeah. But hey, ask me questions on Discord if you have any particular questions on material. I think I will be importing the test at some point over the weekend, so I will know more. But like I said, virtuals will not be on the test. This stuff that we learned today is the cutoff. And if there's a question that shows up in the test that you don't know the answer to because we didn't cover it, then just remember the question, or just remember you ran into that situation at least. And then after the test, approach the TA and tell him, like, this question I don't think was something we covered, and then you will get 3 points for the question. Well, assuming, of course, that it's not something that you just didn't study for, or like that you missed, you know. But yeah, we don't unfortunately have. It's a lot of material to cover, so yeah. But hey, I think at some point, like in the summer session, I did a review, so you could watch a YouTube video for like review of 202 in summer. But I made those tests, so it was different because I knew what to review. Here it's RNG, and I can't leak any test questions because that would be bad and unfair for the other sections. So I haven't seen them myself, but I kind of have an idea based on what they did before. You should all be okay. Don't worry, there's a curve too, so it's just not for the test. It's just a class curve. So I wouldn't be too worried about it. Just do your best. Okay, that's it. That's all I have for you. Thank you all for your patience, and make sure you get your assignments done. The more you code, the better off you will be. Like, trust me on that. That's the best way you can study for coding. It's just to code. Just code, 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 and code, and code, and you'll be good. There's really not. Remember, the test is open notes, so like, there's no reason to memorize anything. It's just coding practice. Keep a cheat sheet, if you're worried about terminology, but it's just coding. It's code. So I can't say that more than just code. Like code, 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 code. That's all you need. Okay. So yeah. All right then. Thank you all for coming. Wishing you all a good weekend. And we'll learn virtuals next week. All right. So, bye everyone.